So before starting with the discussion, so we are very clear, what is today's content, right? What is today's webinar? So it is more closely talking about, the bridging the gap between basically in academics and industries. And when I mentioned the term gap, this does not means basically that I mean, either we are going to choose academia or we are going to choose industry. But if we are choosing anything, how the skills and the improvisation of the skills helping us to be in the front layer or in the front tier of the industry or in the domain of vertical. Okay, so I'll be giving a short discussion on this, and coming to the next slide. So whatever things I'm discussing here, this is all with respect to my personal opinion, and this is solely for the educational purpose only. So this is what I have for you, and if you see, we'll be closely discussing about what is the career advances and what we do in academics and industries, and deconstructing bioinformatics. So if I'm going to break the word bioinformatics, if I'm going to just spill it into multiple, or basically into kind of broad disciplines, how does this looks like, skills and advances, and we'll focusing on one of my specialization, that is on multiomics, and we'll be talking closely on multiomics, which includes about NGS, which includes about practices in NGS as a term of pipeline engineering, and also the technology and the cloud we use in this entire area. So when I say about cloud, I'll be more specifying in the slide. Okay. So going to the first content. Okay, so if you see here, so bioinformatics as a career. Okay, so definitely I'm sure that every one of you have heard this word bioinformatics, and even also I heard this word just after my bachelor's. Okay, I was not aware about it before that. So it's a very recent discipline. If it's basically, it's not that old. It's like around 12 to 15 years, something kind of that. It's a kind of very recent discipline, and this discipline is growing actually. And the good thing is, it is growing much more effective as compared to any of the other disciplines available. So if you look to any of the job prospects, if you look basically to any of the domains, we say that data science is the fastest growing discipline, right? So I believe data science with some domain is the fastest growing discipline. And if I add the domain bio here, it somewhere comes to the bioinformatics. Okay, somewhere it comes to the bioinformatics. So it has basically two of the kind of features. Okay, so the two features are, one is that what you are bringing to the table, and the other is how you are using the table. It means one is basically what are the skills or what are the requirements that is needed for all the domains. So if you see to this part, so these are the skills that you see over here, and these skills are needed for all the domains. So you can work on any of the domain that you are interested. It's up to your specialization, up to your choice of interest. Okay, but these skills that you see, these are the versatility you need to have in each and every place, for each and every domain. If some of you still believe that can I do bioinformatics without technical knowledge, so my poor answer will be little bit no. I will not say complete no, but I will say little bit no, because when I'm putting the word little bit no, it means you may be able to do, or you will be able to do, but you'll be starting in the back bench, not in the front bench. Okay, so these are the wide areas of bioinformatics that we use in the basically in structural biology and multiomics, in translation informatics and engineering practices. Okay, so I'll be coming to these things details in the next slides. Okay, so we'll be talking here. So here, if you see, this is basically how bioinformatics is basically interacting with translation bioinformatics. So what do you mean by the word translation? So translation is basically something which is very closely happening with the individual data, or very closely which is happening with the disease label data actually. Okay, so there are multiple ways to solve the questions that we work in any of the diseases. First of all, we should ask this question in this way: that why do we work in bioinformatics? So I cannot work in any other domain. So why they, I mean, what I'm going to do in this bioinformatics, and if anything is been happening in the bioinformatics, how it is happening. The first aim of working on any domain is you are solving or you are addressing any problems or any challenges in with respect to drug, with respect to diseases, with respect to, you know, kind of computational scalability. Okay. So drug means assume that if any drug is there, so you if you're having cold, so you may take basically D-cold or basically, you know, kind of any of the kind of flu-based medicines, right? But also there are some medicines which are I mean comparative to that medicines, this is 2x times faster. Correct. So how the medicine basically got 2 or 3x time faster actually. So some added research has been happened, right? So some more drug repositioning and drug purpositioning based research has been happened, right? To make the drug much more scalable, much more, you know, effective, or much more the target much more effective basically for the condition, isn't it? So you know that there are a lot of proteins available basically. If you go to PDB, if you go to, you know, multiple places, Uniprot, you'll be seeing a lot of protein structures are available. But that doesn't mean the structure which is available for hemoglobin or basically, you know, for any other protein targets, that is the final structure. Maybe the structure has been generated by X-ray. After 10 years, the same structure also has been generated by cryo-EM or some other technology, in which if in the first structure the amino acids there are like around 100 amino acids, in the second structure there are like around 120 or 130 amino acids. So it's always a improvisation. What I meant to say. Okay. So now, talking all those things, translation bioinformatics is basically is a method where we are interacting with any of the components that is used in bioinformatics to make sure that we are using the right choice of informatics and to make the data informative as well as make the data or make the entire information more scalable. Okay, so this is basically what is the main focused. So now if we talk about bridging the gap as per to our webinar attender, I mean agenda, and basically, so we know that many of us we work on academics. We know that many of us we work on industry, right? So why there are ways and two labels of basically name labels or name representations. Like if you go to academics, then there is some, you know, kind of standard growth. If you work on industry, there is some, you know, rapid growth. As per to my concern, there is no stagnant growth and there is no rapid growth. There is always a growth which is a choice decided by yourself itself, by what you are going to do. Okay, and this choice basically comes up what skills you have, how better you make the decision, what better you make choose and choice your project, what you think that you will be doing after 5 years, and what recent trained and career out path you are adopting actually. Okay, so if you work in academics, the good thing is, of course, you are basically, uh, as the term suggests, academics, right? But the good thing is basically you are working and you are focusing more on your basically career, more on the education part to get, you know, some uh, advanced degree, a kind of higher degree, as well as to gain more knowledge on some specific domain. Specific domain. So here, a domain chosen is very specific, and you are keeping yourself to grow as much as you want using multiple skills. So here, when you talk about the word industry, here domain is always not a constant because that depends basically on which project or on which company you are working. So your domain is always a variable here, but you keep on learning and keep on growing. So when you keep on learning and keep on growing, so that the few things that happens basically, you know, that how uh, good skills you are having, what competitive skills you have, how better decision you make and you make to choose, what projects you choose to work on, and what to think basically like where you will be after 5 years. And again, this is a very simple thing that I wrote actually. I believe this thing you already have used in multiple of the ways in multiple other inclinations. So when I completed my 10th and I came to 12th or basically came to graduation, who said me to do science? I can also have done arts and commerce, right? So who said me that? It's not only parents, right? It's even of my own choice. It's even also I have seen basically, I have read multiple things. I've seen that, hey, if I'll be doing a science, then I'll be going into this direction or that direction, right? So here I am focusing on my decision making skills. Maybe the skills are not that concrete, but still I am going to have a habit on that. right? Right skills. What do you mean by right skills? There are multiple ways of doing multiple things. Okay, if I'll take a very basic example of preparing tea. Okay, so there are some of you who can prepare tea in 20 minutes, who can prepare tea in 10 minutes, or in 5 minutes, or basically who can prepare tea in 15 minutes very consecutively. Okay, so if you take that as an event, then there are multiple skills of doing that. There are multiple ways of doing that. Correct. And if you have been working like for 3 to 4 to 5 6 months on that specific thing, I'm pretty sure you're going to make it very nicely. Correct. So this is basically one of the skill that you are adapting to make the event much more successful. Okay. Choice of projects. This is a very big thing. So many of basically when we work on companies or when we work on academics, we always say that, hey, in background, I have not got a chance to work on this. I have not got a chance to work on that. So are we responsible for this, or the person with whom we work, they are responsible for this? I will solely say that we are responsible for this, because the person, before choosing the person, we are the only who has chosen him or her, right? We have chosen basically either to do continue our career degree, as well as basically my career in terms of industry or in terms of as an employer from them, right? So I'm not going to responsible that. So it's my choice. If I see that if the things are not going good, either I have to make it good. If it is not happening, then I have to go to some other place. What after 5 years? This is a very big question actually. If you know, assume that you are just a master student as of now, right? Or you have just completed your PhD and you have been attending this webinar, right? So if you are a master student and if you are doing all those things and you are in 2023, assume if you know, as of now, if you know only 5% of it, do you believe after 6 months you can change it to 10%? Then next after 6 months you can change it to 15, 20%, 20%, 30%, and so on. So this is what I mean is upskilling. When I use the word upskilling, this looks something like this to me, the graph. If you are able to do this fastly or slowly, you are keeping on growing on your domain, or you are keeping on growing on your decision making, or basically on your choice. But if sometime it happens, this becomes something like this, then you are, of course, you're not growing. This you need to constant focus on. Yeah, so we'll go to the next slide here. So as we discussed basically, okay, so that there are multiple ways of treating to a or basically addressing a basically disease, or addressing a basically condition and focusing on that, right? So the fastest and the closest way of doing that thing is, see, either we can use, so in bioinformatics, as you know, either we can use basically a structural biology method. Okay, so and second is basically your omics method. So omics method means, when I write the word omics, OMICS, omics means we are taking data, and through data, basically, we are doing all types of analysis and we are doing all types of interpretation. And the data is the data can be from anywhere. But when I'm talking about structural biology, it's basically not with the data, but with the structure. As the name suggests, structure, it's basically the structure. So as we everyone know, basically we are having primary, secondary, and tertiary structures of the of the amino acids, of the proteins, right? So what is the challenge between this and this is, if I'll show you something very clearly in a very subset, basically kind of very close subset. So the first thing is, we start with, if you look to this central dogma, this part, okay, we start with DNA, then mRNA, then protein, then metabolite, then we come to the drug markers, and from the drug markers next, basically, we come to clinical trial, clinical data management, pharmacovigilance, then basically clinical data analysis, that is, we call it as like clinical SAS, okay, and then clinical drug discovery, CDD, clinical drug discovery. So these all things to happen basically. So actually it starts from here, and it ends in here actually. So if I'm going to choose a way of structural biology, so what the challenge is, first of all, the number of sample taken here is limited. I cannot take 100 protein structures and I cannot go straight forward, right? So I have to choose basically, some limited protein structures, again from some limited samples, I have to work on that and to make sure whether the structure is available or not. If it is available, then of course we can have to go to the dynamics and we have to find the drug candidates. And if the structure is not available, we have to design and prepare the structure. We have to model the structure, basically taking the best model available. Okay, I'm not going inside more details to what is RMSD and basically how to predict the structure actually. So, and then next is we do some molecular dynamics if you are aware, and that is basically done, to make sure that that is basically done to make sure that any proteins are present in human beings, right? It's not present outside. So if we are preparing or designing any structure in the computer, we need to make sure that we are kind of additional water atoms, hydrogen, carbon atoms, whatever needed, right? And then once the structure is stable through dynamics, then we go towards, kind of the other path known as drug discovery. So this part looks very long to me. This looks very long to me. 8 to 10 years approximately, or 5 to 6 years. If it is a new work, then certainly 8 to 10 years. And from that phase, once the drug candidate is available, it comes to here where the clinical trial starts. Okay, so you understood, right? So now can you assure me and can you write a paper and just say me that, hey, if I am using 8 to 10 years to find a drug basically for a cancer, after 10 years I'm going to use that drug? It should not happen that in clinical trial the drug got failed. Who is responsible for that? Are you going to refund my money to the academia? There are multiple questions. Okay, but if we choose the omics category, basically like working with the omics part means either genomics or proteomics or metabolomics, as I mentioned over here. Okay, or basically any of the other omics area. The beauty of this is here, as we know, this is a personalized medicine, or this is a basically precision medicine part. So here we itself start with the bulk data of 2000, 3000, 5000, 10,000 samples itself. But there is very less chance of failing these things in the clinical trial. Second thing, these things takes entirely only few months to come to the clinical trial stage. We can take an example of COVID actually, how fast the things happen. Okay, so now I believe if you have overally understood, right? So what is the essence of those things? But if I look any of the common thing which is available in this structural such part as well as in the omics part is, the technical side, which I said before two of my slides, right? So people work in genomics, in transcriptomics, in proteomics, in metabolomics, as well as into multiple domains. The reason if you in India and abroad, you will be seeing genomics is much more active, but not others. And the fast and primary reason for that, why genomics and transcriptomics, basically, like when I say about genomics, again transcriptomics is a part of genomics. Okay, so most of the things were active basically in India and abroad. The reason is it is it's very less expensive as compared to proteomics and metabolomics. The expensiveness is the fast thing, because when I work on proteomics and metabolomics, GCMS and LCMS are the fast components. MALDI and TOF are the fast components which comes in CRs, in crores actually. Whereas if I purchase sequencers, which is needed basically to sequence the data and basically to work on genomics, it comes in few lakhs. That's all. Okay, so that's the reason. So if you know, basically, if you look to India closely, basically like how many of users they are using, a kind of Windows and Linux, you know that most of the users come up, using Windows, right? Very less they use Linux operating system, because they know that Linux is not that much compatible and that much not that much user friendly as compared to Windows. So this is something very same layman example how I gave. Okay, so we understood this area, right? So if I'll personalize, or if I will just summarize what I said in detail, give me a second, please. So if you see this side of the part, this is how the omics looks like. Okay, so if you see this part, basically, this is how the entire omics looks like in 2023 or in recent years. So where you'll be having your from genotype, from DNA, you'll be having your genomics. Okay. Also, if it is central dogma, we're having proteomics, proteogenomics, metabolomics, and all these areas. And certainly, if we are working with data, somewhere, sometime we'll be working on ML, right? And somewhere, sometime we will be doing any statistical approach for that, right? So this is basically what are the things. So now you have understood basically what are the domains are available in bioinformatics. And second thing is what things we do basically, or what are the best practices we do in bioinformatics. So if you look to this slide, here I have mentioned this part, right? And I said that this part is very common for all the domains, isn't it? So what we will do, let us look to the skills that we have in that area. So I call it as a technical hands. In technical hands, basically, when you see any of the kind of, like any of the fresher or any of the PhD is going to start, at least they should have, some hands-on experience, not on everything, at least in something. So what is there, at least in something I have mentioned over here. These are the quick go parts. Okay. And this is basically the technical hands in details. Okay, so these all technical hands basically does happen in industry much as compared to academia. The reason is it's not that academic is not having that knowledge. It's certainly because academic is very wide and very diversified, and the things take a lot of time to come to the approval process and basically to start and initiate of the things. Whether in industries, always the best practices comes in the front layer. The reason is we are having multiple competitors, and we are bound to use recent technologies as a solution, as a service offered solution. Okay, so if you see this, these logos basically I have showed over here, and these things. So these are kind of good to go. I mean things basically for any of the fresher basically who is choosing to start up with their career in bioinformatics or in genomics. Okay, so this is what is the impression on this. I will not take you to in detail of this thing. I believe my next colleague who is going to present, he will be talking about these things in detail, but this is what is the essence. Okay, so this is basically the technical part, right? Like what you understood. So technical we'll be doing for some domain, right? Of course, we can do technical for something. We are not typical programmers, right? So we can do all the technical things, isn't it? So these are the domains basically, if you see. Okay, now it depends in your career which domain you want to choose. Either you want to stay in this one, you want to stay in this one, or this one, or basically this one, or this all four, all five, how you want to grow and how you want to choose. It basically depends on the choice of your uh, career path, what basically advantage as well as, basically what next communication you want to do with your skills basically. I mean for in terms of working with different tiers of company or basically different organizations. So that is your choice basically. We'll go to the next slide now, which is very important I believe for this discussion. Okay, so career tips. Okay, so certainly you must be hearing multiple webinars basically, I mean available in India as of now. So I don't know how many of you have got a chance to hear about this. So I thought to have this on my slide because I have been speaking these all things since last 2.5 years in multiple forums. But to this audience, we'll be glad to share. So coming to career tips, okay, and this is very much essential. Okay, again, the disclaimer is it's not mandate and it's not mandatory everyone to understand or everyone to accommodate what I wrote here, because it is very personal subjective, and it's basically the sense of intake varies from person to person, and this all comes from the experience, and with that experience I have basically added here. The first thing is right upskilling. So when I say about right upskilling, it's basically having skills in your profile. So when I say about skills, it's not exactly like you go and do whatever you want to do. Always be sure what you are going to do and why you are going to do, for whom you are going to do. You have worked on a domain X. Assume I have been working in history and civics, and I did my PhD in geography, and I'm applying for chemistry. Okay, this is a very good example what I can say you here. Okay, so certainly if you see this example, what I said you now, okay, this is not right upskilling, right? Okay, so I have to be very precise. I did my basically I mean I started having interest in history and civics. I then focused my PhD in archaeology. Then I went to a place or some basically country to find about the ancient architectures or cultures or scriptings. sculptures, etc. Right? So here you see there is a pattern, a flow, but here there is no pattern of flow. So right upskilling is very much needed. Presentation and communication and communication development. This is very useful actually. You know what? Many of you may have knowledge, but you don't know how to present it. And many of you have communication skills, but you don't know how to communicate it actually. Okay. And when I say about communication skills, it's not about speaking right English. It's basically speaking about right words in right place with right terminologies as well. Remember. So for example, if I'll ask you to say about yourself for 5 minutes, you said about yourself for 5 minutes, and you what you did, you recorded that. The same you are going to play in front of you, and you are going to hear it, and again you are going to speak about yourself for a 5 minutes after 3 days, and again you are hearing that recording. Same thing you are doing 5 to 6 times in a week. So do you think you will be having a best fit video? So for example, if you are saying about yourself, all the videos will sound something similar, right? Why there is a difference? Or something must be much conclusive and something must be much distractive, right? So this is what is the communication I'm talking about. So how focused basically you are while sharing your knowledge or basically while sharing your information. Okay. So that communication you need to have. What exactly is asked to do or what exactly you are doing, how focused you have been presenting, presenting it that and having a communication on that. Second is going after better job responsibilities and connections. What does this mean? This is a very important thing. Many people after masters or after PhD they go with any kind of job. They go with any kind of things. Okay. See, we are not doing job. See, yeah, this is true that we are doing job basically, for a sake of getting salary, getting salary as well as to have our own livelihood. That's not matter. We are also doing job to have something in our CV, right? Isn't it? To have a career, right? To have some information basically which we are going to gain as a experience, right? So have to be very careful with respect to job responsibilities. What we're choosing. It's not key. We completed a masters. Let's join this. Let's join that. Then after 6 months, I got panicked. Then I said, there's nothing in this industry. Let me come back. No, this to and fro is very bad. Basically, no. You have to be very concrete and very sure what you are going to do. And the second thing is connections. What I mean about connections. For example, if you're going to purchase anything from Flipkart or in Amazon, before purchasing, you basically used to see the product, right? You used to see the review and the ratings of the product, right? You used to go to YouTube and you used to check, right, whether the product is uh, exactly how you are expecting or it is something different. So if you can do these all things, at least purchasing for a product which is around 1,000 or 2,000 basically or some dollars, then why can't you do that for your career? Reviewing and understanding what should be the best practices, best skill, as well as best job responsible for yourself, isn't it? Understanding best career growth for yourself. You have done a lot of review here. You understood there are 3 or 5 things. I'll be the best fit, right? Now, what you are going to choose yourself, and if you are choosing yourself, will you be able to switch company multiple times? Will you be able to clear all interviews in a fast shot? Will you be able to basically, complete or be in the front layer basically in the competition? If yes, then choose that. If no, then prepare. Or if yes or no in that phase, then you need to do this thing once again. Scaling up productivity and multitasking. This is a very big thing actually. Why I call this as a very big thing? Because I have heard from many of the peoples and also in India, and in abroad, basically we have seen parents, right? Okay, hey, tomorrow you are having exam, you prepare for this. I'm having basically after 3 days, I'm having some work. I'm only working on this. So what I mean to say is, any person also can do multitasking, right? I do 8 to 10 things in a day in the same time. Do I have a habit of complaining it? How you are scaling up actually? You have been asked basically to prepare a presentation. You have been asked basically to prepare something. Basically, you have got some assignment. You have been working on a project, right? So does that mean if you're working on that project or in that assignment, you cannot do anything else in parallel? If no, then you are good for nothing. You should be multitasking. You should know the art of multitasking. It's not engaging your mind in one place rather than engaging your mind in multiple places and just making it more optimized and more scalable how needed actually. And this is needed actually. If you want to have a better career, this is needed. If you want to have a career as it is going as like, there is no problem. Second thing, best decision making, PhD or a job. Okay. Many people after masters, they come up with a kind of breeze saying that, hey, I'll go for a PhD, I'll go for a research, I'll go for a job. Have you ever thought of going for a wildlife photography? Which is completely out of the box topic I said as of now. So first of all, you need to understand why PhD, why not job, why job, why not PhD? Can I do job after that PhD or can I do PhD after that job? You have to understand these few factors. If PhD after that job, then you have to be very precise on the above thing what I said. If job after PhD, you have to be very precise how impactful it is going to be in your career. While doing a job, you are getting $2,000, but after PhD and when you did PhD and then you joined one second job, you got $1,200. Then what's the use of doing PhD? Right? Same vice versa applies for everything. So you have to be very sure about your approach and very sure about your decision making. And if you remember the example that I have given you here, this example comes straight fit to here also. Avoiding toxic work environment. Wherever you work, make sure your mental health never gets affected. If that this is fine, go deeper however you feel like. If you see in any work, any of the place your mental health is getting affected, certainly the place is not good for you. It's a plan, it's a time basically for you for a change. Breaking comfort zone with versatility. And this is a very big thing. When I say about this, it means not that you are a only person who knows biology and they cannot do programming. You're not a only person who knows programming and you cannot do biology. It means you cannot teach. It means you cannot do job. No, you have to break a comfort zone. Actually, you have to find a way to break the comfort zone. Okay, so these few things basically, so there are more tips actually, and there are more precise tips. I give it on very high level actually, but these are the few things that you need to have while working on any of the domain and while working on any of the career out path, specifically in bioinformatics. The reason why I'm saying these all things in bioinformatics, because bioinformatics is not a la carte. It is a buffet where you'll be having more than 50 plus or 80 plus items actually. You need to be very precise which item you are going to have in your basically starter, dessert, and main course, or else you will end up saying, hey, I just had only 2 items or 3 items. Okay. I didn't got a chance to explore other things. No, you have to find a way to explore. So today topic will close quickly. So if you remember today topic basically, so it's basically pipeline engineering. Okay. So pipeline engineering, I'm going to only share about few facts. So when I say about pipeline engineering, what does this mean? You must be aware about multi-omics, right? So multi-omics means the way that we do, basically work on the omics side, right? If you remember, either on genomics, proteomics, or on any of the other omics area, right? So in all those omics areas, we start from somewhere and we end in somewhere, right? We start from here where we get the raw data either from one individual or from multiple individual, and we end in somewhere, right? Correct, right? So in this process from here to here, there are multiple ways of writing the logic, writing the pipelines, or doing the engineering work. So when I say about a pipeline, it means you are writing some script, or you are writing basically some events or some process or some ways to go from here to here through a programming language, or basically through a non-programming platform, however you feel like. So when you go from this place to this place, there are multiple ways actually. Multiple ways means, in the fast space, if you see, this is a GCS MS, right? It's a gas chromatography. This is some sequencer. This is multi-top. Okay. So and here somewhere it is a clinical metadata, like clinical data, patient data, whatever it is like. So once you gather the raw data, assume here is the raw data, You have to make your data processed, right? So to make the data processed, what people used to do before, they used to understand which analysis they are going to do, which pipeline they want to use, whether the pipeline is available open source. Open source means it's freely and publicly available or not. If not, how they can get the pipeline, or else can they bring a publicly or a free pipeline and they make some customization and can use it for themselves or not. There are multiple ways, right? Then after that, they used to get some valuable as well as some kind of sensible or important results. They are basically wandering in their space, right? So if we break this entire concept, we'll be breaking it to three major areas. So when you see, I have drawn this one. So this is basically the way, I mean, these are basically the important keywords which we get very closely if we analyze any of the things. So either it can be helpful for a patient information, for the genomics and clinical data, and whatever things will look like, right? And for this entire pipeline engineering scope, we have divided it into three parts. So one is your primary, secondary, and tertiary. What is primary? Primary means you are starting it from the very basic raw data. The data, the digital data. If I use the word digital data, it will sound much more better. It's not only data. The digital data is in a very raw format. I'm running something on that data to make the data something civilized, and I call it a secondary analysis. And then on that, I do some additional interpretation for to get anything specific of my choice of interest. I assume for a specific disease or for a specific condition, and that I call as tertiary analysis. Okay, so here in this entire thing, there are multiple technologies. There are a lot of technologies we use inside this. And what's the reason of using technologies? If you go to multiple companies in India, you must be aware. If you go to multiple academics, basically in India and abroad, you must be aware. Many of people, they work on DNSSEC analysis, right? But all they don't do DNSSEC analysis in a single way. Many of them basically they work on RNA-seq analysis, right? But they don't do RNA-seq analysis in a single way. Okay, so what are the varieties of that? So this is basically what I understand about the technologies. I will not to walk through into the technology part more in detail, because that is basically a certain an extension of our courses which Shika and the team will be talking about it, that if you want to learn, how you learn those things. So this you understand basically on a very high level what is a pipeline engineering, right? So when we do all this kind of pipeline development, pipeline engineering basically for NGS as well as for multiple other disciplines, we of course need to have some kind of server, right? So without a server we can't do the things, isn't it? Okay, can you do a thing without a server? I certainly believe no, because in bioinformatics we need a server for sure. Okay, so there are two ways of having server. One is that either you are using any on-premise server. So when I call about on-premise server, it means any server which is present in a location, actually in a typical location. And second is, last few years we are much more or very well aware about cloud services, and these are the types of cloud services. AWS belongs to Amazon, GCP belongs to Google Cloud Portal, Azure belongs to Microsoft. So what is happening is we are using basically any of the cloud services, any of the cloud practices where we can make sure that we are doing computational thing in a much more scalable and effective way. And why it's needed? The first of all, if there is any server, physical server anywhere located, okay, of course this will be having a lot of hardware cost. Actually, it will be having a kind of standard backup, a lot of maintenance cost. A person has to maintain that, right? And again, assume that you have a very small task to do. For example, you have to find what is even number and what is odd number in basically 1 to 100. I'm saying a very small example. Then for to run this small program, why you need 28 GB, 128 GB of RAM? This also you can do in 2 GB of RAM, right? So this is basically use the resources or use the computational specs how you wish to do. I want to work 5 hours in a server in a day. I worked for 3 days. Rest 4 days I am basically in vacation, right? Why I'll be purchasing a server of some thousands of dollars are basically, or in lakhs basically, and then I'll be putting it in my ecosystem. So it's better I can use some cloud servers. I can pay how much I use. Simple. Okay. Now I don't want to come in terms of security and how the usages are, but bioinformatics practices strongly been happening since last few years in cloud servers. If you go to Nature, if you go to Science publishers, as well as I mean other journals, you can get to know structural biology, protein folding, alpha folding, Rosetta folding, kind of protein folding things basically using alpha fold and Rosetta fold, NGS, and a lot of other things have been happening. And currently in today's generation, many companies, they are transiting to the cloud services since last few years, and some of them are doing wonderful. Okay, so this essence and this knowledge also you may need to acquire, you may need to understand if you want to be into the development, or basically into the kind of in the upskilling basically of your career in terms of bioinformatics. So this is basically what are the overviews. I believe you already have gathered your questions and basically your questions and answers. We'll be sharing answers with you. Sorry. Okay. I believe you, and if you have any of your kind of doubt and discussion, certainly you can write to us. So there is a Q&A basically to take on those things. And coming back to my background before wrapping up the call. So as like you, basically, I also completed my master's in bioinformatics in some certain time. And after that, I was also having a lot of dilemma whether I should go for job or go for PhD, and then with a lot of basically yes and no, yes and no. Fortunately, I understood that let me get a chance to go for PhD. But once again, very fortunately, my PhD got delayed uh, again in one of the university in UK. So I got a chance basically to work with corporate, and then I closely started my career in this. And I have been working since last 7.5 to 8 years in this corporate. So in past, I have worked with TCS R&D, with GSK, with MapMy Genome, and currently with Genomics England, and in past, just immediate past with Genomics England in UK. So it's overall of 8.5 or 9 years of experience, both into technology domain, as well as into multiple business areas, and into teaching and client communications. So these all things I learned with time, and certainly I have also got some PhD offers before 1.5 or 2 years. But again, I'm very precise to see whether what to accept, what to not with respect to my skills. So the only reason I'm sharing with this thing with you, you know, you have to be very curious and you have to be very specific with your decisions. I believe let your decisions help you to earn a good salary in the end of every month. Best wishes.